Hello, yeah. So let's get started today, and I hope everyone can see the board. So in today's topic is completely based on linear algebra session. Last class we have done some specific questions, so it will be a continuation on that because we didn't manage to finish all the questions on that session. So mainly we have discussed about 7 to 8 types of problem which will keep on coming and keep coming into different examinations. Remember that while the live class is going on, you can ask me questions at this number 98367 93076 or to the number from where you get the broadcast there as well. Okay. So today there will be an extended session till 10:15. Okay. Now, as I was saying, okay, one more wants to get added. So in linear algebra's questions, mostly application of theory based questions comes in, as you have seen. Okay, and remember that while doing the questions answers, if you are new today, if you haven't done the previous sessions, then also it's not a problem because I will be doing it from the basic now. Okay, and remember that in one of the two types of questions, if you see that there is a specific zone, for example is a zone wise data here. For example, what is a zone wise data? So let me just give you an equation, y equal to 2x plus 3. So linear algebra says that x is the independent and y is the dependent variable. If I say that 2x square plus 3z plus 5, then there are two independent variables which are defining the dependent variable. So this is a better way to explain. But if I say that x1 plus x2 plus 3x3 plus 4x4, so there are four independent variables which are defining the values of y. So if I keep on increasing, the number of variables, for example, if I give you x10, so this must be a relatively better situation to explain this, isn't it? So enhancing the number of variates always is better, but with respect to statistical analysis, when you guys do, okay, it's a mathematical perspective of it. So sometimes it is called, in order to make the data look important, sometimes a lot of extra variates are being added to the system which are useless actually. So we have to dodge all those things as well. I will teach you how to do that. For example, in a matrix, for example, what is an augmented matrix? So last day many of the questions are discussed with that. For example, if I take a equation x1 plus x2 plus x3 plus x4 equal to 5, then 7, 3, 8, x1 minus 2x2 minus 4x4 and x1 minus 3x2 plus x4, x3 plus x4. So if you form that augmented matrix, and the rank of these matrix with respect to the main matrix are the decider, isn't it? Many questions we have done it like that. 1, 1, 1, 1 are the coefficients. If I just replace them, 1, minus 2, 0 and minus 4, then 1, minus 3, 0 and 4, and 0, 0, 1 and 1. Sorry, if this is the thing, and if I take the RHS like this, so this entire thing is the augmented matrix, and this is the main matrix formation. So if the rank of this matrix is equal to this, less than this, these are the decider. Rank calculations become a very crucial thing for this data structure. Okay. Now there are one or two different types of cases in this happens when okay, remember that one of you have asked me what is a zero row. Zero row doesn't mean, for example, is it a zero row? Answer is doesn't matter. Which one is a zero row? For if it is matrix 1, if it is matrix 2. So which matrix has higher number of zero rows? For example, matrix 2 only, and that is only answer 1. So matrix 2 has a 1 0 row and matrix 1 has 0 0 rows. Remember that here column doesn't matter. Number of 0 rows. 0 rows means all values are 0, not higher number of zeros. Clear? So the number of zeros are the determiner, not the determiner. Whether everything is a zero or not, that is the crucial point over here. Okay, so we just take out a PDF once. Question 7. Yeah, you can do that. You have created the way she has done, if you want to know. So she has created an augmented matrix, and infinite possibility means she has changed the rankings, and that is one. So every time I have done it like in that way, so here I try to create a new way only. So another way of 6 is augmented matrix and then equalization of rank, and there will get alpha beta value. So there also you can get this equation. One 2 minus 1 0 3 1. Now n of A is a null space of A, and R of B is the range space of B. Then the dimension of n of A intersection R of B over R. next one. Okay, sorry, I haven't solved it. Okay, sorry. चलिए इसको फटाफट सॉल्व करते हैं. So A and B are linear transformation, isn't they? Aren't they? This is a simple linear transformational structure. Okay, this is A, and for B's point of view is, so for R of B, one 0 is 1 minus 1 and 3. And so 2 0 1. So basically R of B here and 2 0 1. So now as we want elements of NA intersection of RB, so then actually we want the elements of RB whose image is under the linear transformation of A, isn't it? So whose elements transformation of A. So this is a null space, directly we can form it out. R of B. So here you can solve it directly. So for this we can say that these two, so that is 1 2 0. Okay, so this is finally we can calculate 2b minus u 0. So 2b equal to u, so x y z here. So dimension of this thing is equal to 1. Next one is question number 8. Okay, let M be a matrix with real entries. M is a n cross n matrix. Such that MQ equal to I. Suppose that MB equal to V, not equal to V, for any non-zero vector V. Then which of the following statement is or are true? M has real eigenvalues. Remember that whatever we are doing in the class, almost everything comes in. Okay. B M plus M inverse. M plus M inverse has real eigenvalues. See, n is divisible by 2. And D is n is divisible by 3. So here in this case, how we can proceed? N into n matrix with real entries. Given that MQ equal to I and M is a n cross n matrix, so MB not equal to V for any V. So MQ equal to I and MB not equal to V. So this thing gives us one thing, that 1 is not an eigenvalue of n. Now, if we go for the minimal polynomial of M that divides NQ minus 1. Divides NQ minus, means I, identity. So now let lambda is the eigenvalue of M. Lambda is the eigenvalue of M. Then M of lambda q minus 1. m of lambda. So this is a minimal polynomial and cannot have a factor, can't have a factor, lambda minus 1. Okay, as 1 is not the eigenvalue, so the only possibility is m of lambda is lambda square plus lambda plus 1. So the eigenvalues are omega and omega square. These are the two EVs. So obviously option A has a real eigenvalue, one single real eigenvalue and rest of them imaginary. As complex roots always appear in conjugate pairs for an equation, so there is an order of the matrix must be divisible by 2. So clear? So option number 3 is correct. Order of the C is correct. Now if M is n cross n, मान लेते 2 cross 2 matrix, and that satisfied m square plus m plus 1 equal to 0. So obviously n equal to 2, which is not divisible by 3, at n equal to 2, this is not divisible by 3. As a result of that, D is not a correct answer. Lastly is m plus m inverse. Inverse अलग से होगा, so that's why I kept it till the end. So m plus m inverse is equal to, so m plus m inverse, if I just put it into this equation, m square plus m plus I equal to 0. M is invertible as determinant of m equal to 1. So m is invertible. So in this case, so we try to reduce the power here. So m plus m inverse plus I equal to 0. M plus m inverse equal to minus I. Okay. So as all eigenvalues are minus I and minus 1. So the eigenvalue of m plus a inverse, one of the eigenvalues must be minus 1. So here it has a real eigenvalue. So
are we assuming the determinant to be 1?
Which one?
The determinant of m, are we assuming it to be 1?
No, not assuming. So for example, if you see that if it is not 1, then we cannot reach to any of these things. So if you see the question also, let M is an n cross n matrix with real entries and MQ equal to I. So this is only possible if the determinant value of M is equal to 1. So yes, the main presumption is, or main deduction rather say, is determinant value of M is 1. So here also in the second case also we have shown it like this. Okay. So time for the next one, 9. P is a 7 cross 7 matrix. In general, linear algebra is easier than scoring once you do it properly, and rank equal to 4. Let A equal to, A belongs to R7, be a column vector. Then the rank of P plus A plus AT. So rank of P is what? 4, and rank of AAT is 1. A into A transpose, so that also give you rank 1. So rank of P plus AAT is less than equal to, again that old rule, so rank of P minus rank of AAT is less than equal to P plus AAT. 3 less than equal to rank of P plus AAT less than equal to 5. So obviously rank of P plus AAT, this thing, is at least 3. So the minimum value of this thing is 3, or they have asked a value. So if they have asked like this, any value between 3 and 4 and 5 is the answer. Otherwise minimum value 3, max value 5 in that way also, or the least value or the maximum achievable value. Ten. Number of solutions. Okay, number of solutions. Now V1 equal to 110, and V2 equal to 011. Let M be the matrix whose columns are V1, V2, 2V1 minus V2, V1 plus 2V2. In that order. So columns are in this order. Then the number of linearly independent solutions of the homogeneous system of linear equations in Mx equal to 0. So I'll do that. Next. So how to solve this one? So V1 is this, V2 is this. So 2V1 minus V2, another one. This one. 2, 1 minus 1. V1 plus 2V2. One, 3, 2. So M equal to 1, 0, 2, 1, triple 1, 3, 0, 1 minus 1, 2. So clearly, so third and fourth are linearly combination of V1 and V2. So third and fourth are linear combination of V1 and V2. So rank of M is equal to 2. So rank of M equal to 2. So the homogeneous system Mx equal to 0. Number of linearly independent solution. This is one very important theory. So number of linearly independent solution will be 4 minus rank of M, that is 4 minus 2 equal to 2.
Sir, how do you consider that 4 minus rank of
M.
yes?
Yeah, rank of M is here also. You can do it in this way. Number of these are the two linear combinations of each other, so that only left out with these two, that will be a rank. Or you can do it by direct method of echelon matrix formation. So here I try to do every problem with a different variety. That's why I took this way out. Otherwise, we can do it with the normal echelon. So 1 0 0 0 1 0 formation will occur. You can see that the number of, so it will become the lowest one will become 0. So a number of non-zero rows. So rank of M equal to 2 in that way also can come. But the main theory to focus in this case is this part. Okay, so let's go for the next one. Any questions on this? Okay. Let the eigenvalues are alpha, beta, gamma, delta. Find the values of sum of alpha square.
So can you just repeat the question, sir?
Yeah, sorry?
So can you please repeat the question?
Yeah, this is the matrix and these are the eigenvalues. You need to find out sum of alpha square. Means actually alpha square plus beta square plus gamma square plus delta square.
Is it 0?
Tell me how you got 0. 0 won't be the answer, I think. Next, so what will be the solution of this question? So this is a matrix. So this is a companion matrix. So the characteristic equation is lambda 4 minus 2 lambda cube minus lambda square plus 2 lambda equal to 0, where lambda is the eigenvalue of the matrix. Let's take lambda common. So alpha, beta, gamma are the roots of the equation if you take. So alpha plus beta plus gamma equal to 2. Equal to minus 1 minus 2. So now alpha plus beta plus gamma whole square is, we know the formula, alpha square plus beta square plus gamma square. This is 4 minus 2, so this is 6. 6 is the answer. As I said, 0 won't be the answer because otherwise the square equations will not be formed properly. Next, question number 12.
Can you just repeat the equation, sir? How can you get it, sir? Can you just show the process, sir?
Yeah, so it's it's a companion matrix formation. So companion matrix के लिए इस तरीके से directly you can write it from here with respect to the given structure. In the last to last session, I have done it in class also. So I'll send that classes link. So how the companion matrix is actually. So anyone know what is a companion matrix? You have forgotten. So it's a square matrix defined in this format. So why it's a companion, let me just say you. For example, it is matrix of X. Then again 1, then 0 1, M1, so M2. In that way it goes on, and then 0 0 0 and 1, M of n minus 1. So there has been a linear recurrence relationship. So from that, this characterization of the formation comes in. Let's go for the next one. And if this is the matrix, then the polynomial, the monic polynomial is, if it is m of x, m0, m1x, m2x square, m mn x, sorry, not mn, then mn minus 1, so 1 into n. So here you can see that if if you see this formation, it starts with a 0, starts all the zeros, then 1, then minus 1 1 1, and this is the value here. Okay, so they are the main deciders. Now is it clear how I got it? Good. So these kind of theories become handy in most of the cases. R is a polynomial function of degree less than or equal to 3, defined on R, and let T of V to V is defined as T of f of x is fx minus x f dash x. So then the rank of T. Is it 1 or 2 or 3 or 4? T of f of x, this is the main formation. T of f of x. So T of 1 is 1 minus x of 0. So 1. So 1 plus 0 into x, we can say T2, or sorry, Tx, x minus x, is equal to 0, 0 into 1, then T of x squared. So this is x squared minus 2x squared, that is minus x squared. So this is 0 into 1, 0 into x, minus 1 into x square and 0 into x cube. Last one is this into x cube, so x cube minus 3x square into x. So x cube minus 3x cube, so this is minus 2x cube. So 0 into 1, 0 into x, 0 into x square, minus 3 into x cube. Sorry, 2. So finally we can write the T in this form. Hence rank of T is 3. Only 1 0 row, rest of them are non-zero. So obviously option number C is correct. Is there a problem in understanding this one? Okay, any questions to make the PDF of it? So I think the companion matrix played a very crucial role in that question. Need to keep the theory on for that.